your score on the team?
All right, look at number 4 on the skills practice. So we'll work this problem the way that we worked yesterday, where you get it into slope intercept form, and then let the calculator do the real work. So when you don't have an x and a y, you just need to decide which one you want to be x and which one you want to be y when you get it into the calculator. So it looks easiest to make the t the y, because then all you have to do is add the r to both sides, and so you get t. Hold on. You get t equals r minus r plus 5, and then you get t equals 2r plus 4, and then you put it in the calculator as y equals x plus 5, and y equals 2x plus 4. What was it? Y equals x plus 5, right? Oh, that's not y equals. And y equals 2x minus 4, or 2x plus 4?
Plus 4.
And then you just go to your graph. Okay, now in this case, my window was messed up from something else I was doing, so I may want to do a zoom 6, because the calculator won't do the intersection unless it can actually see the intersection on the screen. So once the calculator can see the intersection, do second trace, 5, enter, enter, enter. Intersection is 1, 6. So that means in that problem, if x is 1 and y is 6, x is 1 and y is 6 means x was r and y was t. That's what you want as your answer. If you write it as a coordinate 1, 6, when it has the letters R and T, then that usually means in alphabetical order. R comes before T in the alphabet, so that means that one's probably R and that one's probably T. Otherwise, write it like that. Say R equals 1 and T equals 6. Now that's using the graphing method. Now, we're not going to do very many problems, only 6 using elimination and 6 using substitution. But here's the process for elimination. I did. It came in this. I checked your question. Yeah. Then I had to reboot.
Okay. Next one has the same issue, so I'll have to do the same thing you do.
Okay. So in this problem, what we need, and just to remind you on elimination, is you have to have everything set up so that all the same types of terms are lined up. Usually standard form works pretty well. So the R terms came first, the T terms came second, the equal signs were lined up, and then the constants were the only thing that was on the right. How many of you remember doing elimination? That's not enough. For those of you that don't remember, you should be paying attention. So what we're trying to do is get it so that, well, add the two equations together, I add vertically, and I add these two terms, the r terms together, add the t terms together, add the constants together, but I need either here or here to become 0 when I add. Now right now it's not that way, because if I added right here, it would be really pointless. I wouldn't accomplish anything. That would become negative 3r plus 2t equals 9, and I haven't accomplished anything by doing that. Instead, you may have to adjust one of the equations. For example, if I multiply this equation by -1 times -1, then I'll end up with positive r minus t equals -5. If I leave this one alone, -2r plus t and 4. So what I have here is I have the exact same term, the exact same coefficient, the exact same letter, but just opposite signs. So when I add them together, r minus 2r is a negative r, and t and a negative t becomes 0. This is what I need to happen in either the r's or the t's. One of the two variables has to 0 out. Because then, after I get rid of the 0, if negative r is equal to -1, multiply both sides by -1, positive r will be positive 1. That is the key. That is half of my solution, and that's the key to finding t. Because now I can take this value, plug it back into either one of these two equations. It doesn't matter which one I choose. I'm just going to choose the top one. Unless one is a lot easier than the other, don't beat yourself up trying to figure out which one to put it in to use. -1 plus t equals 5. Add 1 to both sides. T was 6. Good job. So that's what we got the other way also, right? Now number 5 is already good, because when you add right now, the y's will cancel. You'll have 6x plus 0 equals -3, and then you can solve for x, plug that back in, and find y. So you didn't have to adjust either one of those. Same thing with number 7. They're already going to eliminate. Let's look at number 8. Okay, on number 8, you can decide if you want the z's or w's to cancel each other out. And you can probably do either one. One may be a little bit more work than the other, but don't confuse yourself or worry about if you're doing the right one or not. If I wanted the w's to cancel, what should I multiply by in which equation? Remember doing this? If I want the w's to cancel, what can I multiply this equation by? By what? Close. -2. And that would give me negative 6W plus 8Z equals negative 16. And that would get the W's to cancel. But look what else happens. 0 plus 0 equals 0. Is 0 equals 0? Yes. And so if everything cancels out and you get the same numbers equal to each other, that means that these two were exactly the same equations. And so it was two lines right on top of each other. That was infinite solution. Now, if you ended up with something where at the end it was 5 equals negative 5, that's not true. And that would be a no solution. Let's see if we get one of those in a minute. All right, so that's elimination method. Let's look at substitution. Now, in the substitution method, what you have to do is similar to what we did in graphing, where you have to get one of the letters by itself, but you only have to do it for one of the equations. So if you look for where there's only one of the variables with an exponent or with a coefficient of 1, and there's nothing in front of any of the, that would be u in the second equation. So it'd be real easy to get u by itself. U would be negative 2x plus 3. So what you do is when you get one of the equations, when you get a variable isolated in one of the equations, you take the other equation and you substitute this into it. So instead of writing 2u plus 4x equals negative 6, if u is equal to negative 2x plus 3, then I'm going to put negative 2x plus 3 here where u was. And then use algebra from there. Distribute, get negative 4x plus 6 plus 4x equals negative 6. What happens? You combine like terms, and what happens to the x terms? You get 6 plus 0 equals negative 6. So this is a situation that we talked about in the previous problem. Is this true or false? And so there's no solution. And if there's no solution, then we know that these two lines must have been parallel. That's probably what you got, hopefully, for number 10 on the skills practice side. That's probably what you got when you did it using graphing. You got two parallel lines. Two equations that had the same slope but a different y-intercept. Does 13 have a solution? Those of y'all that are finished? Okay. Let's do 13 then also. On the skills practice side. Let's do 14. I'm pretty sure 14 has a solution. So we're going to do 14 using substitution again. So in the first equation, C doesn't have a coefficient. D has a 2, this C has a -2, this D has a -5, but there's nothing in front of C, so that's going to be real simple to get by itself. C would be equal to -2D minus 2. Just subtract 2D from both sides. Then I take the other equation, which is -2C minus 5D equals 3. And where the C was, I'm going to substitute in what C is equal to from the first equation. And the reason this is helpful, the reason substitution is helpful is because instead of having two equations and each equation having a C and a D, which doesn't get me anywhere, now I have one equation that just has D. And so I can, using algebra, I can get D by itself. And I can actually get a value for it. And then let's go through the algebra. It becomes 4D plus 4 minus 5D equals 3. Combine my like terms, I get -D plus 4 equals 3. Subtract 4 from both sides. -D is equal to -1. Multiply both sides by -1, so I have a positive D, and that'll be equal to a positive 1. Now I can take that and go right back up, put that 1 right there in the place of D, and then I can find C real easy. C is equal to -2 times 1 minus 2, which is -2 minus 2, or -4. So your answer should be C -4, D 1. So that's using substitution. Find a variable you can easily get by itself, and then take what that's equal to and plug it into the other, and take your answer and plug it back into what you started with.